home camera, you're drunk. Okay. All right, guys, I know you're not all done, but I got to start catching up to you. Go home, projector, you're drunk. All right. All right, guys. This first one should have been really nice. Yes? Yes. What's the integral?
Yeah. Yeah, that's it.
And then I almost don't care, but don't you get 30 minus negative 2?
Yeah.
32? Yeah. Okay. Integral secant squared. Tangent. From 0 to pi over 2. Tangent of pi over 2 is?
Pi over 4.
Pi over 4.
Is it pi over 4? Oh, I can see. I can almost see it. Tangent of pi over 4 is 1. Tangent of 0 is 0. So it's like 1 minus 0, correct? You got to do the difference of the antiderivatives evaluated at the endpoints. This one had a couple things. I could take the 2 out of the way, first off. Then I got twice ln of the absolute value of x evaluated between these. Twice ln of negative 1 absolute value. That's going to be 0. Minus twice ln of absolute value negative e. It's going to be twice 1, so minus 2. I get negative 2. How we know so far? And that kind of makes sense because 1 over x is negative back here, yes? So I'm going to get a negative area I want to evaluate back there. Okay. This one was neat, but basically the integral of a function is the function whose derivative is inside the integral. Because the integral is an antiderivative. And I know that the derivative of 3 to the x is this. Therefore, the integral of this is 3 to the x. 2 to 3. So I get 27 minus 9. So I get 13. No, 18. Okay.
Oh, you were making fun of me.
I was.
That's really
You didn't have to tell anybody, but I was.
No, it's funny.
Thank you. And this, I know that the derivative of e to something is itself, but that can't be the answer because if I took its derivative, a 3 would come down for the chain rule. Therefore, there must have been a 1/3. That thought process is so beautiful. If it's just a constant, I can always balance that out. And then from natural log of 2, what just happened to me? Natural log of 2. So I got 1/3 e to the 3 ln 3 minus 1/3 e to the 3 ln 2. If I pull those up to be powers, it'll be e to the ln 20. So it'll be 27 over 3 minus, pull that up, 8 over 3, right? And that, of course, is 19 over 3, which is good enough. Okay. Woo! And again, for each of those, you can just plug it in the calculator and do the number 7 calc thing, and it'll tell you if you got it. Okay. All right. Now, what about these? These are just asking for antiderivatives. So what's this guy's antiderivative? Yeah, this came from an x to the negative 1, and then it would have a negative that would try to come out, so the negative's there to kill it. Or you remember that the rule for the integral x to the n, as long as n is not negative 1, this integral is x to the n plus 1 over n plus 1. Holy shit, if you can see what I'm writing. So there's the rule for anything where n is not negative 1. Because we know if n is negative 1, that's the natural log. And then, of course, minus. There it is. I like it. And this one I always get interesting answers, but what is that? It's just. Try again. Pi t. That's better. I don't want to see no frickin' x's. This problem has no frickin' clue what x is. All right. So yeah, I will start being a little more, especially when you guys do stuff like x squared minus t cubed plus x plus c. I'm like, what is your variable? All right. You don't want to be in Calc 3 yet. Calc 3 is where you have multivariables. You don't want to be there yet. Okay. what do I do with this thing? Yeah, simplify. So I get sine theta over cosine theta over 1 over cosine theta. The over cosine thetas cancel. So I get integral sine theta, which is negative cosine theta. I love it. And this is a good example of changing gears. You're thinking backwards, right? So I can also hear the gears, and I can see the smoke coming out the ears. It's really weird going from one derivatives to antiderivatives, right? You got to go back and forth. Okay. This one's not that bad, really. All right, this is x to the, what is this? X to the, good, roots on the bottom, over x squared, which will be x to the 1/3. 4x over x squared is 4x to the negative 1. And then I get plus 2x to the negative 2. So basically just simplify, because again, integration does not have any direct product, quotient, or chain rules.
Where do you get the 1/3 if it's 7 over 3?
Oh, divided by x squared,
Oh.
which is 6/3. So I'm left with 1/3. So you got to take each of these divided by this, each of these divided by this, each of these divided by this. So I simplify it. Is that cool? And now what do I get? X to the 4/3, and what goes out front? The reciprocal of that result. And of course this, I've written it kind of weird, but what is this? Absolute value of x. The absolute value. And then this, we just did it, right? We just did it basically, right? So isn't it minus 2x to the negative 1? Plus c. There it is. Did anybody get this one? Here's the first step of this one. Or you can do long division if you'd rather. You like long division better? Some of you guys are like, I love it. Some of you guys are like, yes, please, long division. Whatever. 1, negative 5, negative 2, 10, 10. Yes? So this will be, what does this mean? This means that it was x squared, now it's x minus 2 plus 10 over x plus 5, and this is easy shit. Let me do the hard parts. Here we go. Whew. All right, now you guys do the easy part. What's this one? 10 natural log of plus c. Why is that easy? Because it's basically 1 over x. Because that plus 5, it's still linear slope 1. So it's got to be easy. There's no chain rule I have to worry about. Maybe? All right, that was a little quick, but that's all right. So, last thing for today. What time we got? Oh, we got a little tiny bit of time. I love it. Little tiny bit. I had something prepared. Where did I put you? Who knows, Jeff? No. There it is. Okay. It's nothing too special, but let's see. Is your teacher organized? All right. Now, let me ask you what should hopefully be a very straightforward question. What is this? Yeah, nothing fancy here, right? What does the d something part really tell you? The du. It tells me that the variable is u. I like it. Anything else, this integral sees as a constant. Du means u is changing, which means any other variables that are there aren't changing. Okay. So it's not a big deal, right? This is some easy shit. 1/3 u cubed plus c, or u cubed over 3, however you like to write it. So, what if, how do I say this? This is going to be neat. What if u was x squared minus 6? X squared minus 6, let me think. Yeah, what if u is x squared minus 6? What is du dx? Yeah, isn't So if u is x squared minus 6, what's the derivative of this? 2x. Is that cool? Did anyone want to put a plus c there? All right, good. Your brain starts to go, what direction are we going? So isn't this true? Do you guys remember differentials? Can't I write it like that? Yes? Is that cool? Just kind of multiply the dx up. So look at this. What does this become then with those replacements? Doesn't that become the integral? What's u? What did we say u was? X squared minus 6, right? And what's du? 2x dx. And we're claiming that this answer is going to be 1/3. What was u? Is everybody with me? Didn't I make substitutions here? This is true, period. Yes, you guys had no problem. You just said, that's the frickin' answer. And you didn't say, if u is x. No, you just said, that's the answer, right? So what could u be? You could be anything. I like it, okay? So then, this is supposed to be this. Is that true? What's the derivative of this? What's the derivative of this? 3 comes down. Derivative of this. 3 would come down, cancels. X squared minus 6 squared times 2x, which is this, yes? Okay, now. I really want you guys to follow this. This is backwards from what we're going to do, but I like this example because it's very concrete. The beginning problem is true, period. Yes? The beginning problem is just true. Did it have any restrictions on u? The only real restriction is it's got to be differentiable, right? If u's not differentiable, this kind of goes crazy because I need du, yes? But other than that, it's got to be almost every function we look at. So what if u was this? Du would be this. The integral would have looked like this, and the answer would still be in that form. So the whole idea, remember when I said, why is this integral doable without having to do anything? Because the derivative of this is in here. Yes? Is this integral in some way easier than this integral? Is this integral, do you guys agree with me? This integral is easier in a little way than this one. Because the 3 is there, right? So it gets worse. I mean, so we cannot do, you can do it, Jeff. We cannot do this integral right there. It is impossible for us to do this integral right now. I really, does anyone not understand that this would be impossible for us to do? Because I want the integral of sine of something should be cosine of something. But what is it missing? What is this missing to be doable? It's missing the chain rule piece. So this integral is completely doable. You can do it, Jeff. There you go, buddy. This integral has to be easy. Because does it have the chain rule piece in it? Yes. So what's the integral of sine? Negative cosine. And what is the derivative of this? Wouldn't it be sine this times the derivative of the inside? Isn't that exactly what that is? That was easy because it had the chain rule piece there. Not even just easy. It was possible. So if I'm missing a number, who gives a shit? I could throw a number out front and put the number inside, yes? Aren't these the same now? The inside here, sorry? Yes? Okay, now, so here's what we do. What if I had this? What do you got, Jeff? Oh, yeah, sure. Sure, okay. should this be doable? Why is this something we should be able to do?
Because it has the chain on the
Yeah,
outside.
the derivative of the inside is in there. So here's what we can do for ourselves to make this a little bit easier to look at. We can kind of come back. Wasn't this easy? Remember this very first problem we did? That was easy as shit, yes? So if I kind of work backwards, what is the inside piece? What's the inside function? 2x squared minus 3, right? What is its derivative? Or its differential even? 4x. So if I put a u in place of this, what must be in the integral? I must see 4x dx. Do I see 4x dx? Yes. So that means, let me rewrite this. I'm going to write more than I normally would. I'm just going to put the 4x dx together. What is this? What can I replace this with? Du. And of course, this becomes secant squared u. And what's the integral of secant squared u? Tangent u plus c. And the last step you have to take, because the problem has no freaking clue what u is. I got it. What was u? Sorry. Minus. There we go. There we go. So this is in this form because the derivative of the inside is in there. So I have to be able to write it. And isn't this a much freaking nicer? It captures what's going on. Now, if I saw this, could I do that? Well, no. If I say u is the inside, du is 4x dx. Do I have a 4x? I'm screwed. I'm screwed. I don't have in there what I need in there to be able to write it in terms of u. So this is remarkably enough. Us math geniuses called this process u substitution, or affectionately also known as u sub. So I've got an example up here. Right? This is doable because here's the inside and its derivative is in there. Now, I really want you guys to be cool with this. Is the derivative of this actually in here? What's the derivative of this? 3x squared. Do I have 3x squared? No. But can't I put a 1/3 out front and a 3 there so I balance things out? Yes? Maybe? If I put a 1/3 in front, that means I can multiply the inside by 3, right? What did I just do? I just did nothing. I always think about Indiana Jones, and he does that. He didn't balance his equation right, so the boulder came down and survived. So somebody who's never seen Indiana Jones and the Raiders of the Lost Ark?
Down the ride, but I haven't seen the whole movie.
Okay, you saw the boulder part?
No. Oh yeah.
Okay. All right. You should see it. You should see every movie made in the 80s, basically. That's when they knew how to make movies. All right, old man, shut up. So, let me see. Yeah, that's plenty. So, we'll do this next time. I just wanted to get that in your brains.
Did we skip 5-4?
And it won't be on the quiz, right?
No, 5-4 is indefinite integration. So that was the second part of the handout.
Oh, okay.
Sorry?
It won't be on the quiz.
No.
Just till 5-3.
Yeah, the quiz on Wednesday is 4-9. What did I say? 5-2?
5-3.
5-3.
You can make it 5-2.
Look at you guys being
That's
honest.
fine.
Wow.
Doesn't have to.
I've got the video. That's one reason.